Hello everyone, and welcome to our lesson on reaction types. There are a few other reaction types than the ones I'm going to show you right now, but these are just the classic basic examples. So let's go ahead and get started. The very first one we're going to talk about is a synthesis reaction. Down here I have our little catchphrase, dating. This is where you take two simpler molecules, usually elements, and you put them together. So we've got a general form here. Sorry, wrong side of the paper here. You take a cation, a positive, and you add it to a negative anion, and when you put them together, they form one compound together, and you notice that the cation is always first, and the anion is always second. So even if they're not in the correct order over here, you need to make sure that you properly put them together over here. So an example I have of this is magnesium and oxygen will burn to produce magnesium oxide. And guys, again, remember, oxygen is a diatomic molecule, hence you see the 2 as the subscript, and then you have to then go back and forth and change the coefficients to get that reaction balanced. Now, anything that can come together can also split apart. So that comes to the sad part of our story. Instead of dating into a wonderful budding relationship, we get a decomposition. Decomposition reactions are where something breaks up. Now, it can be very simple with a compound like this, where we just have simply a cation and an anion, so A and X here, and it simply breaks down into just back to the cation here and the anion there. There are situations in life, of course, where this can be a little bit more complicated, and you don't just have simple elements, you also have some compounds, and when they break up, they don't always break into both simple elements. They might break up to an element and then another compound over here that is simpler, of course, than what we started with. So again, the key is that it breaks into pieces. An example of this is actually when we split water. So in the electrolysis of water, we take it and we split it into hydrogen and oxygen gas. Again, hydrogen and oxygen are both diatomic molecules when they are alone, so don't forget to write those properly, and you'll see the coefficient pairs be balanced. Now, the next reaction type is a little bit more of a funny story. In this, we have single replacement. Single replacement is where we have essentially a dance going on. So what we'll see here in this is you see A and B are going to simply switch their places. So A is going to come in, kick out B, and take their spot. Now you notice in this case I use the blue side of the rainbow. So A is a cation, and he's going to come in and replace B, who is also a cation. And so you'll notice that where B was written first, A is also written first over here with letter X. Now, this, how I think of it, cations, you could call it a he. In chemistry, you must replace like with like charges. So your positive cation must replace a positive cation. You cannot replace a negative anion. You cannot put two positives together, and you can't put two negatives together. The other kind of single replacement is very much like this, except for the fact that you can have an anion replacing an anion. So in this case, you'll notice that Y is going to replace X, and you'll notice that, Y then ends up sitting where X was, coming on over here and sitting with A, but of course written second. Anions are always written second with X. Now, because there was two, I didn't put a specific single replacement reaction. We'll get a little bit more specific with these a little bit later, because sometimes people can say, no, I don't want you to replace me. The next one is another one like dancing, where you have one replacing another. This one is where two switch, so I like to call this one do-si-do, meaning swing your partner's do-si-do. So what happens in this is that you take, and you don't have to switch the cations, you can switch the anions. I like to go ahead and switch the cations. So you'll notice here, A and B will switch spots. So then A is going to go with Y over here, and B is going to go with X. So to take a look at an example of this, we see lead 2 nitrate and sodium chloride, that the lead and the sodium switch spots, and you end up with sodium nitrate and lead 2 chloride. Now the last reaction type that we are going to talk about today is one that is fun, and we'll get to do a demonstration of this a little bit later, but it's called combustion. Now hopefully you've heard of combustion. You see my flames over here. This is explosive. With this one, there's not a nice little pattern. You don't worry about which cation replaces which cation or an anion switching locations. Simply with this, you have a hydrocarbon, which is just the number of C's with number of H's. So we have C subscript X, H subscript Y, and again, those can be varying numbers. You react it with oxygen, and your products are always water and carbon dioxide, and of course a lot of energy, hence the flames there. So that is our short, brief lesson. We will expand upon those reaction types a little bit later. Hope you learned something new.